Okay, there are a couple that I'm going to mark off. There is number 39 that is dead, and number 48 that is dead, because that involves a type of algebraic manipulation that we're going to see later on in the class, so I'll cover it at that time. So go ahead and skip numbers 39 and 48. They will not be showing up on your test. Number 22 is negative rad x plus 2 is less than or equal to 2. Now, first thing I'm going to do is I'm going to move this radical to the other side by multiplying both sides by negative 1. What I do is I get rad x plus 2, and since I multiplied by a negative, I'm going to flip my inequality, and that should be negative 2. Now, theoretically, this should be all real numbers, right? Because whatever jumps out of a radical needs to be positive, which is always going to be greater than negative 2. However, we still have a bit of a domain issue here, where x plus 2 has to be greater than or equal to what number? Has to be greater than or equal to what number, people? 4. 0. The inside of a radical has to be positive, right? So x has got to be greater than or equal to negative 2. And that's your answer. Right? So that's number 22. Let's go on to number 49. Absolute value of x is equal to 4. Here, you break it up into two problems. Negative x equals 4, x equals 4. So on this one, I'm going to multiply both sides by negative 1. I get x equals negative 4. Daniel, how you doing back there? Do I need to move you from Catherine in front of the whole world to see on YouTube? All right, that was number 49. '93 is similar to the one we took on the pop quiz, so negative 7 plus 3i over 2 minus 5i. If they just give you a problem that looks like this, they're going to ask you to rationalize the denominator. Daniel, what's up, buddy? Okay, sorry, thank you. They're going to ask you to rationalize the denominator. So what is the conjugate of the bottom? Daniel. 2 plus 5i. Okay? So since the bottom is a conjugate, I can just go ahead and go 4 minus 25i squared. And I squared we know is negative 1, so 4 plus 25 is 29. This top we actually have to FOIL out, so this is going to be negative 14, negative 35i, 6i, and then positive 15i squared. I gotta get rid of some of this junk here. Okay, I squared is negative 1, so that's negative 15. So this is going to become negative 14 minus 15 is negative 29. And then that's going to be minus 29i. Kind of cool. All over, what did we say this was? This was 29? Oh wow, this is kind of cool. What's gonna reduce here? All the 29s. Negative 1 minus I. Pauline. Say again? Because what this expression is each one gets a 29. Okay? That's why this becomes negative 1 and this one becomes negative I. Koki. Uh-huh. Oh, I didn't graph it? Well, if x is greater than 2, if x is greater than negative 2, that's going to be on the number line. So it's going to be if x is greater than, it's going to look like that. $49. Oh, we're supposed to graph it? Okay, sorry. If we were supposed to graph it, that means that it's true. Then we get x equals -4 and x equals 4, right? So what that is, Koki, is at 4 and at -4, we get two horizontal, vertical lines. That's what that is. Okay? All right, so that was number 49. We just did 93 also, right? Okay, 99. We did this one yesterday. 106. My personal preference with problems like this is that if you see an entire group, Carter, if you see an entire group being raised to a negative exponent, the first thing you need to do is flip that entire group. Now, the thing that's going to throw people off right now is why didn't the y's change position? Why are they still negative? And that is because they flipped due to the -2, not because of their own thing. Right? They flipped because of the -2. So now we can start simplifying some stuff a little bit. 6 divided by 3 is 2 up top, and that's going to be negative. X to the 4th over x to the 4th, well, that's gone. These two y's are going to change position, so it's going to be y squared over y to the 5th, and don't forget all of that's being squared. Let's keep going with this, because the y's can be simplified. I get a -2 over y to the 3rd on bottom, and that's being raised to the 2nd power. And now, since all of it's being raised to the 2nd power, I'm going to get 4 over y to the 6th. That is number 106 for you. All right, next one here. 112. Two x to the 0 all over 3x minus 1 squared. What's anything to the 0 power? 1. So that's gone. That's the easy part. I would actually accept this as an answer because there's nothing else you can do with it unless you really wanted to FOIL this out, in which case you'll get 1 over 9x squared minus 6x plus 1. Okay, that was 112. Let's go to 137. Factor completely. Okay, 4x squared minus 36x plus 81. Whenever I see a problem that looks like this, and I see a 4 and an 81, what types of numbers are they? They're a very special type of number. 4 and 81 are a very special type of number. What are they, Riley? They're perfect square roots, right? So I'm going to just guess that this is 2x minus 9 and 2x minus 9, because it's not 2x plus 9, because that would be a difference of two squares. But let's just check and see if it works. I got a -18 and a -18. What's 18 plus 18? 36. Are these the right factors? Yes, they are. Pauline, which question? It is number 137, yes. Oh, just kidding. That's 139, sorry. 137 is little bro, big bro. 137 is little bro, big bro. So that is 27x to the 3rd minus 64y to the 3rd. Okay, they just threw a variable in there for you. But with little bro, big bro, you just break it down exactly the same way. What is 27 expressed as something being cubed? Trevor? 3 cubed. And x cubed is x cubed. Trevor, do you know what 64 is as something cubed? 4 cubed. Good. And y cubed. Now we have little bro and we have big bro. What goes inside little bro? Cameron? 3x minus 4y. Good. Now, does it make sense that when I use one of everything, I have 2 left? Yeah? Okay, what are the end caps of big bro? Pauline, do you know what the first end cap of big bro is? 9x squared. Do you know what which takes care of all this, right? Do you know what the last end cap of Big Bro is? Who knows what the last end cap is? Carter. 16y squared. That's where this goes. How do we get the middle term of Big Bro? Ayush. Multiply little bro together. So what do I get here? Just 12xy, right? Don't worry about any signs because the symbols are going to come last. What are the symbols in Big Bro going to be? Riley? Double positive because this one, the first term is opposite little bro. This one's always positive. You're done. Little bro, big bro is not going to go away. It's coming back in a couple of chapters, so make sure you guys know how to do it. Where are we at? We just did 137, 159. 159. Where is it? Ah. 5 minus rad 6 times 2 plus rad 6. Okay, it's a FOIL problem. First, 10. Outer, plus 5 rad 6. Inner, negative 2 rad 6. And then last, negative root 36. Well, these are going to combine. That is 3 rad 6. What is the square root of 36? Riley? 6. Now, it's not 6i this time because the negative's on the outside. So it's negative 6. So all I have to do, the hardest part of this problem really is 10 minus 6. What is it? Is it really that hard? 4. So that was 159 for you. 190. Okay, this one's a bit of a factoring bear. Where is it? 18 x to the third plus 16x equals 34x squared. Okay, I'm going to go and subtract 34x squared from both sides because whenever you have a bunch of different x terms, it's always good to get all the x's to one side. So I'm going to get 18x to the third minus 34x squared plus 16x equals 0. Everyone's always going to forget how to factor this. What do they all have in common? They all have an x. They all have something else in common. They're all even, which means I can factor out at least a 2. But let's see what I get on the inside. Maybe I can factor out something higher. 9x squared minus 17x. Looks like I'm up the creek on that one. Plus 8 equals 0. Okay, so now I'm going to get 2x. And then this is going to be equal 0, so I get, let's try 9x and x. I know it's going to be negative, negative. What are two numbers that multiply to 8? 2 and 4? 2, 4. Here, 36 minus 2. 36 and 2 can give me 17. When I add them together? Nope. Try again. Ayush? 4 here and 2 here. 18, 4. Nope. 8 and 1 in that order. 9, 8. 9 plus 8 is 17. And they're both negative, so it's negative 17. We're good? Good. Okay. From here, 2x equals 0. 9x minus 8 equals 0. X minus 1 equals 0. What does x equal in each situation? This is a no-brainer. That's 0. What does x equal? What does x equal in the third situation? Ilias? Okay, in the second one, it equals 8 over 9. What does x equal in the third situation? Carter? 1. All right. There's the first stretch. We'll answer some more questions in a few minutes. Keep going. From here, a linear inequality says we subtract 3 from both sides. 5x is less than 15. Divide by 5. X is going to be less than 3. From here, you graph that thing on a number line. 3. It's an open circle because we don't have an equal sign underneath. X is less than it, which means we're moving to the left. Right? That is how you do number 30. 65. Okay, good question. Whenever you have a situation where you have x's on both sides of the equal sign, like in number 65, again, it's always good to kind of remember that algebra is easy. If I gave you 2x plus 5 equals x minus 7, what's the first thing that you would probably do? Move x to the other side, right? Subtract x from both sides, and you get x plus 5 equals negative 7. This is no different. You're still going to subtract x from both sides, except you're just not going to be able to combine those like terms. When you can't combine the like terms and they have an x in common, what do you think you can do with this problem? What should you probably do? Angel, what should you do with this problem? Once we're here, we did that already? Nope. Carter, factor out an x. Angel, remember we did this? Does this look familiar? Those are going to go away. You get x equals 5 over rad 3 minus 1. However, what do I need to do with my answer, Daniel? Conjugate. Rad 3 plus 1. Rad 3 plus 1. So this is going to be x equals 5 rad 3 plus 5 over 3 minus 1, which is 2. All right? This is a good problem right here because it really kind of tests your algebra skills. All right. That was number 65. 66. Okay. Okay, I'm going to go ahead and subtract 8 from both sides. I got negative 3x rad 2 equals negative 6. I'm going to go ahead and divide by negative 3. So I've got x rad 2 equals 2. Now remember, rad 2 is just a number, and that number is being attached to x. So how do I get x by itself when there's a number attached to it? How do I get rid of that number? Cameron, divide by that number. That number just so happens to be rad 2. So you get x equals 2 over rad 2. So you have to rationalize the denominator, and you get a 2 on bottom with a 2 rad 2 up top. The 2's are going to cancel each other out. X equals rad 2 only. That was 66, so 71. Okay, 71 here. The square root of x minus 7 is equal to the square root of x minus 7. Similar, but very, very different in design. I'm going to square this. That's going to give me x minus 7. I need to square this thing as a group, which means I'm going to get rad x minus 7 here. So I get x minus 7 minus 14 plus 49. Oops, 14 rad x plus 49. I'm going to go and subtract x from both sides and cancel them out. I'm also going to subtract 49 from both sides. So I get negative 56 equals negative 14 square root of x. I'm going to divide by negative 14 on both sides. So I'm going to erase this garbage right here. 56 divided by 14 is 4 equals rad x. I'm going to square both sides. X equals 16. Now, because I had radicals underneath or rather x's underneath the radical signs, I need to check and make sure that the answer was legit. So the original problem was radical 16 minus 7 is equal to radical 16 minus 7. Well, this is 9, so rad 9 is 3 equals, this is 4. 4 minus 7 is negative 3. True or not true? Not true. That was the only answer I was given, which means this answer is actually no solution. Riley, does that make sense? Yeah. The trick, guys, the trick in this problem, the trick that people are going to fall for, is they're going to forget to square the right side as a group. They're going to say, oh, this is x minus 49. It's not. You guys have to remember to square things as a group with that section. All right, so what are you going to square it as? A group. 71, 78. Where are you? Oh, solve the system by graphing? Okay, this one here, they're going to ask you to, this is kind of a bear. And then I'm going to go ahead and convert the other one. This is 2x minus 3y is less than negative 6. Okay, so I'm going to go ahead and subtract 2x from both sides. So I got negative 3y is less than negative 2x minus 6. Divide everything by negative 3. So I got y is greater than 2/3 x plus 2. I'm going to try and find the shared shading between these two, so I'm going to go ahead and graph this thing. It's a good problem. I like this. Okay, who can tell me the shiftage of the first one, the absolute value graph? How is this thing being shifted? Gregory, how is this thing being shifted? That's telling me the type of line it is, but I need to know how it's shifted. Emily, what do you think? To the left 3, 1, 2, 3, down 1, 2. Gregory, how about we start paying attention, okay? It's facing up. Now, the shading is above the graph, which means it's going to be in here. Does that make sense, everyone? Let's go and do the next one. Let's do it in blue. Cover. Then it's upside down. Good question. Okay, next one. Up 2. I'm going to go up 1, 2 to the right, 1, 2, 3. This is a line. It's dotted. Y is greater than that. So my shared shading looks like it's inside this V right here. Okay? That's how you do it. Good problem. That was 78. Let's do 100. Okay, 100. 100 is 4 minus 3i squared, which means this is not going to be 16 plus 9i squared. This is 4 minus 3i times 4 minus 3i. Raise your hands if you're okay with that happening. Okay, good. This is 16 minus 12 minus 24i plus 9i squared. What is I squared? Negative 1. So this is negative 9. 16 minus 9 is 7 minus 24i. 165. X to the negative 6/5 power. That is equal to 1 over x to the 6/5 power. The problem is that I can't have any fractional exponents on the bottom, so I need to rationalize this denominator, but I need to figure out a way to get x to have a whole number exponent on it. 6/5, what's the next number up that I can use to kind of divide by 5 and get a whole number? Esther? Yeah, actually you should. You're going to multiply by x to the 4/5 because 6/5 plus 4/5 is, on the bottom, x to the 10/5, which is x squared. And don't forget your x to the 4/5 up top. $169. Okay. 169 is a radical problem. Rad 24 plus rad 40 plus rad 33. Okay, this one here. Two numbers that multiply to 24 are 4 and 6. Two numbers that multiply to 40 are 4 and 10. And two numbers that multiply to 33, well, we don't really care because that can't be broken down. This is going to be 2 rad 6 plus 2 rad 10 plus rad 33, and that's as far as you can go with this problem. Odd problem, kind of funny. Last one, 181. Good problem with 181. This one will take a couple seconds. Okay. All right. 6x minus 5 to the 1/2. Oh, to the 1/3. Never mind. Just kidding. Not as easy as I thought. I'm going to subtract 2 from both sides, so I'm going to get negative 5. I'm going to go ahead and cube both sides to get rid of this. So I get 6x minus 5 equals negative 125. 6x equals negative 120. X equals negative 20. All right? And if we check it, it'll work. 6 times negative 20, 20 is negative 120, minus 5 is negative 125. The cube root of that is equal to negative 5.